Welcome back to the next session of this course. Now that we understand what generative AI is all about and we conceptually understand the difference between discriminative models and generative models, let's talk about generating content using these generative AI models. If you have used ChatGPT or Google Bard or maybe Dell E to generate images, you know that generation usually starts with a prompt in the form of text or image and a video or any kind of input. This is basically the start of generation process, and it's this fact that generating content is so easy. All it requires is a query in natural language. This is what has made generative AI models so powerful and so widely used today. And this is something that has evolved over the last few years. Early versions of generative AI required using an API or some other complex process to submit an input. It's quite possible that you would have write code in order to interact with a generative AI model, and that's clearly not something that's accessible to everyone. The fact that generative AI models are so accessible today is because of how easy it is use them. Now content generation is using natural language prompts, which makes it democratized and accessible and contributes to their wild popularity. Let's talk a little bit about the characteristics of these generative AI models. Generative AI models of today do not comprise of a single modality. They bring together various artificial intelligence algorithms and techniques to represent and process content. For example, to generate text, you use natural language processing techniques to transform the raw data, the letters, the punctuation, and words into sentences, parts of speech, entities, and actions. All of your natural language text is usually represented as vectors using multiple encoding techniques. Similarly, images are transformed into various visual elements, also expressed as vectors. Once you have a way to represent the world in numeric from behind the scenes, these generative AI models are very complex neural network architectures. These neural network architectures are able to focus on the relevant portions of the input that you provide and generate content in response to that input. Now, this is something that's true of all artificial intelligence systems, but especially true of generation AI in that these models are garbage in, garbage out. Now, because generative AI models train on real world data, their training techniques can result in the inclusion or encoding of biases, racism, deception, and other issues that might exist in the training data. As we will see in the evolution of generative AI, programmatic generation of content has been around for a very long time. You can trace this back to the 1960s. In the early days, programmatic generation of content was usually done using rule-based systems. These are also known as expert systems that use explicitly crafted rules for generating responses or datasets. Rule-based systems can only go so far in generating interesting and varied content. The advent of neural networks and the ability to train them on used datasets really changed the rules of the game. Neural networks were originally designed to mimic how the human brains work. These have the ability to learn the rules of the data by finding patterns in the existing dataset used to train them. Now, the first neural networks existed since the 1950s. That's kind of hard to believe, isn't it? However, these neural networks were limited by a lack of computational power and small datasets that were available. It's only in the early 20s, with the advent of big data technologies such as MapReduce and Hadoop, and the ability to process huge datasets in parallel across a distributed cluster of machines, that neural networks became practical for generating content. It's only then that we had the software and the computer hardware in terms of GPUs in order to train these neural networks. Now, with this little bit of context behind us, let's talk about some of the generative models that we have so excited about today. The first, of course, is ChatGPT. This is the AI-powered chatbot that was launched by OpenAI back in November 2022, and it took the world by storm. ChatGPT's ability to have a conversation with you in natural language and produce meaningful and coherent response to your question was something that we had never seen before. When OpenAI released ChatGPT, the other companies weren't far behind. Google released its own conversational agent for natural language queries called Google Bard. It can perform tasks similar to ChatGPT but is powered by an entirely different model. Another model that's widely popular is DAL-E. This is generative model from OpenAI that allows you to generate images based on natural language text descriptions. The most widely used conversational agents today are ChatGPT and Bard. Let's understand the difference between the two. First, of course, where you access them is different. ChatGPT is accessible via OpenAI site at chat.openai.com. Google Bard is accessible at Google site at bard.google.com. ChatGPT's service is free for the most part, but there is also a paid plan with premium access that's available. The paid plan is around $20 a month, and you get premium access to ChatGPT servers and also access to GPT-4, their latest version. Google has no such differentiated service. Bard service is absolutely free. ChatGPT is available to all, but you need to sign up with some kind of account and either an email account or a social media account. Google Bard is also available to all, but you must use a Google account, either a Gmail account or your Google corporate account. Now, the models that power ChatGPT and Google Bard are very different. ChatGPT is based on the GPT series of models where GPT stands for Generative Pre-trained Transformer. It's a certain kind of model architecture. The neural network architecture that powers Google Bard is different. It's based on model called Palm 2, where Palm stands for Pathways Language Models. With ChatGPT and Google Bard, you will find that the responses you get, the same queries are likely to be different. So it's probably a good practice to use both. ChatGPT's free version has certain limitations because it answers questions based on an information cut-off date. Google Bard tends to be more up to date with current information because it uses trained data and real-time information from Google searches. Now, ChatGPT can analyze images, but that's available only in the paid version. When you get to use GPT-4, the newest version of the GPT model, Google Bard analyzes images as a part of their freely available version. Now, which one is better? Well, it depends on your use case. Whenever I am working, I require generative AI help. I generally have both GPT and Google Bard open. We have discussed the popular generative AI models of today, and in that we included ChatGPT and DAL-E. Now we refer to ChatGPT and DAL-E as models, and that's totally fine in regular everyday parlance. However, ChatGPT and DAL-E are the interfaces to the underlying models that power them. They are not models by themselves. ChatGPT is a chatbot built using a text-to-text model called GPT, which stands for Generative Pre-trained Transformer, and this actually refers to the architecture of the neural network model that powers ChatGPT. DALL-E, on the other hand, is the interface to the text-to-image model that can generate images from the natural language text prompts and very realistic looking images at that. In both ChatGPT's case and DALL-E's case, the underlying model is a mathematical construct that has been trained on massive amount of data. Now, in the context of generative AI, you have likely to have heard the term LLMs or large language models. What exactly are these? Let's discuss that. The natural language models that you have interacting with when you are using ChatGPT or Google Bard are large language models. These process natural language inputs or generate text in response. And the way they generate text is that they generate words in a sequence and they predict the next word to generate based on what has already come before. Based on whatever text they have already generated, they are referred to as large language models because the models themselves are huge. There are billions of parameters in each models that need to be trained. Models with a large number of parameters tend to be able to extract more complex relationships from the input data. They also take longer to train and they need more data to be trained on. That's another reason that these language models are called large. They have large because they have trained a huge corpus of data comprising of billions of records. Over the past few decades, there has always been research into natural language processing, and there have been several advances that have led to the large language models of today. However, the real breakthrough in the development of large language models came into the creation of a certain kind of neural network, the transformer. The transformer architecture was first introduced in neural network design back in the year of 2017 in a paper called Attention is All You Need. Now, transformer networks are sequence to sequence models, meaning they process an input sequence and they generate an output sequence. A natural language is just a sequence of words. As you might imagine, natural language inputs and outputs can have arbitrary lengths. Now you can have input sequence that are very long and output sequence or responses that are even longer. And the transformer architecture revolutionized how we work with sequences by using this innovative concept called attention. We will discuss attention a little more in this learning chapter, but this concept allows the neural network architecture to focus on the right and most relevant parts of the input sequence in order to generate the output. There is a direct line from the transformer architecture to the natural language models that we use today. Now, while discussing generative AI and natural language models, it's important to mention the idea of prompt engineering. Prompt engineering is the process of structuring text that can be interpreted and understood by a generative AI model, and there is a skill and art involved in getting the right kind of prompt to get the most relevant response from your model. That is what we will discuss in more detail in the next video.